Download this code from codegive.com, link in the description below. Understanding and using ClassPath in Java, Geeks for Geeks style. The ClassPath is a crucial environment variable in Java development that tells the Java Virtual Machine, JVM, where to find the .class files needed to run your Java programs. It essentially provides a list of directories and jar files that the JVM will search when trying to locate classes and resources. Understanding how ClassPath works is fundamental for managing dependencies and running your Java applications correctly. This comprehensive guide will walk you through the concept of ClassPath, its importance, how to set and manage it, and common issues you might encounter, along with plenty of illustrative code examples. 1. What is ClassPath? In simple terms, ClassPath is a list of paths that specify locations where the Java runtime environment, JRE, or the Java compiler, javac, should search for user-defined classes and packages. It's like a treasure map guiding the JVM to the required building blocks of your program. Think of it like this: imagine you have a program that relies on other code stored in different places. The ClassPath acts like a directory listing you give to the JVM, letting it know, hey, when you need to find a specific class or package, look in these locations. 2. Why is ClassPath important? The ClassPath plays a critical role in several aspects of Java development. Resolving dependencies. Java programs often rely on external libraries, jar files, or classes defined in other projects. The ClassPath allows you to specify the location of these dependencies so the JVM can find them during compilation and runtime. Without a correctly configured ClassPath, the JVM won't know where to find these dependencies, leading to errors like class not found exception or no class def found error. Modular code organization. When you have a large project, it's common to organize your code into packages and separate directories. The ClassPath enables the JVM to find these packages even if they are not in the same directory as the main class being executed. Custom libraries and frameworks. If you create your own libraries or use third-party frameworks, you need to add them to the ClassPath so that your projects can utilize them. Overriding system classes. In very rare, and generally discouraged, cases, you can use the ClassPath to override system classes that are part of the Java runtime environment, JRE. This is risky and should only be done if you fully understand the implications. Compilation. The Java compiler, javac, also uses the ClassPath to find classes and interfaces needed to compile your source code. If a class being compiled depends on other classes, those other classes must be accessible via the ClassPath. 3. Setting the ClassPath. There are a few ways to set the ClassPath. Environment variable. This is the most common and persistent way to set the ClassPath. It sets the variable globally for the operating system user. Windows. 1. Search for environment variables in the Start menu. 2. Click Edit the system environment variables. 3. Click Environment variables. 4. Under System Variables, click New. 5. Set variable name to ClassPath. 6. Set variable value to a semicolon separated list of paths, example. C \path / to \my \classes, C \path / to \my \jars /mylibrary.jar. The dot represents the current directory. 7. Click OK to save the changes. You might need to restart your command prompt or IDE for the changes to take effect. Linux / Mac OS *. 1. Open a terminal. 2. Edit your shell's configuration file, example /bashrc, /zshrc, /profile. 3. Add the following line. 4. Save the file and source it. Asterisk command line argument, CP or class path. Asterisk this is a temporary way to set the class path for a single execution of javac or Java. Asterisk example, compiling. Asterisk example, running. Asterisk manifest file, inside jar. Asterisk when creating a jar file, you can include a manifest.txt file that specifies the class path attribute. Asterisk this approach is particularly useful when creating executable jars that rely on other jars. 4. Class path syntax. The class path variable is a string containing a list of paths, separated by a specific delimiter. The delimiter depends on the operating system. Asterisk Windows asterisk semicolon. Asterisk Linux / Mac OS asterisk colon. Each path in the class path can be asterisk a directory asterisk the JVM will search this directory for .class files. Asterisk a jar file asterisk the JVM will search inside the jar file for .class files. Asterisk a zip file asterisk, rarely used, but supported, the JVM will search inside the zip file for .class files. Important notes asterisk. Asterisk the JVM searches the class path in the order the paths are listed. Asterisk the current directory is represented by a dot. It's generally a good practice to include dot in your class path so that classes in the current directory are found. Asterisk if you are using an IDE, like IntelliJ IDEA, Eclipse, or NetBeans, the IDE typically manages the class path for you. You usually don't need to set the environment variable directly unless you are running your code from the command line. 5. Code examples. Let's illustrate with some code examples. First, create the following directory structure. Asterisk src/com/example/main.java asterisk. Asterisk src/com/example/helper.java asterisk. Now, create the mylibrary.jar file containing the helper class. 1. Compile the helper.java file. This will create a COM directory containing the example subdirectory containing helper.class. 2. Create the jar file. Now, let's compile and run main.java using different class path settings. Example 1, compiling and running with class path environment variable. 1. Set the class path environment variable, as described earlier. 2. Compile main.java. 3. Run main. Output. Example 2, compiling and running with class path argument. 1. Compile main.java. 2. Run main. Output. Example 3, class not found exception, incorrect class path. If the class path is not set correctly, you'll encounter errors. Let's remove the mylibrary.jar from the class path and try to run the program. 1. If you're using the environment variable, remove ./lib/mylibrary.jar from it, or if you're using the command line, run the command with the incorrect class path. Output will likely show a no class def found error or similar error. This no class def found error or class not found exception indicates that the JVM could not find the helper class because the mylibrary.jar file was not in the class path. Example 4, using a manifest file, with executable jar. This example shows how to create an executable jar that includes its dependencies. 1. Create a manifest.txt file in the myproject directory with the following content. Important, the class path attribute must have a space after the colon, and each entry in the class path must be relative to the jar file's location. Make sure there's a new line character at the end of the file. 2. Create the executable jar. Asterisk CVFM, create, verbose, manifest file, include all files. *myproject.jar, the name of the executable jar file. *manifest.txt, the manifest file. *csrc, change to the src directory and include all files within it. 3. Now, you can run the jar file. Output. In this case, you don't need to set the ClassPath environment variable because the jar file contains information about its dependencies in the manifest. 6. Common issues and troubleshooting. *class not found exception or no class def found error. *the most common issue. It means the JVM can't find a required class. Double-check your class path to ensure it includes the correct paths to the jar files or directories containing the missing classes. Pay close attention to capitalization. Java is case-sensitive. *incorrect path separator. *using the wrong path separator, example : instead of, on Windows, will cause the class path to be interpreted incorrectly. *relative paths. When using relative paths in the class path, make sure they are relative to the directory from which you are running the Java or javac command. The dot always refers to the current working directory. *jar conflicts. If you have multiple versions of the same jar file in your class path, the JVM might load the wrong version, leading to unexpected behavior. Carefully manage your dependencies to avoid conflicts. Use a dependency management tool like Maven or Gradle to handle this. *IDE configuration. If you are using an IDE, make sure the project's build path or module dependencies are configured correctly. The IDE usually handles the class path internally, so manually setting the environment variable might not be necessary. *missing new line in manifest file. If you are creating an executable jar with a manifest file, make sure there's a new line character at the end of the manifest.txt file. Otherwise, the last attribute might not be parsed correctly. *case sensitivity. Linux/Mac OS. Linux and Mac OS file systems are case sensitive. Ensure that the paths specified in your class path match the exact capitalization of the directory and file names. 7. Best practices. *Use dependency management tools. For larger projects, use dependency management tools like Maven or Gradle. They automatically handle dependency resolution, download dependencies, and manage the class path for you. This simplifies the process of managing dependencies. Avoid global class path. Setting the class path as an environment variable can sometimes cause conflicts, especially when working on multiple projects with different dependencies. Consider setting the class path only when running your Java code from the command line and let your IDE manage the class path for projects within the IDE. Create executable jars. When distributing your application, create an executable jar file that includes all necessary dependencies. This makes it easier for users to run your application without having to worry about setting the class path. Keep jars organized. Maintain a well-organized directory structure for your jar files. This makes it easier to manage dependencies and configure the class path. 8. Alternatives to ClassPath. While ClassPath remains an important concept, modern Java development practices often favor alternative approaches that provide better dependency management. Maven*, a powerful build automation and dependency management tool. It uses a pom.xml file to define dependencies, build configurations, and project metadata. Gradle*, another popular build automation and dependency management tool. It uses a Groovy-based or Kotlin-based DSL, domain-specific language, for defining build configurations. Modules. Java 9 and later Java modules provide a more robust way to manage dependencies and enforce encapsulation. They define explicit dependencies between modules, which helps prevent dependency conflicts and improves the overall structure of your application. The module info.java file declares the dependencies and exports. These tools offer a more declarative and organized approach to managing dependencies compared to manually setting the class path. Conclusion: understanding the class path is essential for any Java developer. While modern tools like Maven and Gradle simplify dependency management, knowing how the class path works is still important for troubleshooting issues and understanding the underlying mechanics of Java's class loading process. By following the best practices and utilizing dependency management tools, you can avoid common class path related problems and create well-structured and maintainable Java applications. This guide has provided a thorough overview of ClassPath, complete with code examples, to help you master this fundamental Java concept. Remember to experiment with the examples to solidify your understanding.